Hey everybody, in the next video, I'm going to be talking about degrees of freedom to vary. This is kind of a complex concept, so I want to see if I can make it a little more clear using the stats blocks. What I'm going to do is show a sample and then show how that sample mean is used to represent a population mean, and then demonstrate why we lose 1 degree of freedom anytime we use a sample statistic to estimate a population parameter. So let's look at what we have here. Now this, of course, is our number line. We can tell that because there's numbers on this line. The actual numbers don't matter. They're representing means. Okay? These are data points, and this is a balance. The balancing point is right here in the middle. So here's what I could do. Let me just kind of set this aside over here, and I'm going to just randomly select some data. So here we go. I'm going to roll these out. This is where those fall on the number line. What I would do then, because remember the mean is the mathematical center of the distribution, in this case of the sample. I would have to move this board kind of up and down, kind of dial this in. I think it's going to balance roughly about right there. Put these on the balance, and nope, not quite. So it's going to have to shift, what, this way a little bit, and these we're going to slide that way. Oh, not too far, too far. Coming back, a little bit more. Right. So in this kind of sloppy example, what I've shown you is I calculated the sample mean by sliding this balance up and down the measurement scale. So for instance, if I do another sample, okay, well, that'll be a little bit easier. Those two go there, this one goes here. So those will balance, I don't know, about right. Let's see if this is right. There and there. Nope, so I'm gonna have to go this way just a little bit. Oops, nope, go this way a little bit. So again, sloppy example, but you can see that I've created the balance by moving this balance board up and down the x-axis. Every sample is going to have a new sample mean. Now, here's what will happen when we're using estimators. I'm going to use the mean of my sample to estimate the mean of the population. Here we go. So same idea as before. It's going to balance, I hope, maybe about right there-ish. Okay, put those on, put this one on, and do a little bit of adjusting. Excellent. This is my estimation for a population. So I'm using the sample mean, which is right around 16 in this case, to estimate my population. Give me a second. This is my population, which goes about right there. Let's review what I've done. I've used a sample and the mean of that sample to estimate the population. I don't actually know the mean of the population. I'm estimating the mean of the population from this sample. This is going to be my original sample. That's the sample that I'm using for estimation. Let's remove these. What I have now done, however, is to lock in the mean of the population to this value. In this case, it's 16. So what do I mean by locking it in? What I've said is because I've used my original sample to estimate this population parameter, anytime I do math, I'm going to be plugging in this value, which didn't come from the population, it came from the sample. I'm going to be plugging in this value for all the math that I do. This is going to have implications then for future samples. I'm going to draw another sample, and I'll do it a little bit differently than I have previously. So there's 1, 2, and 3. This sample now has to balance, and it has to balance at 16. I'm not free to roll this die and roll this piece of wood, and wherever it lands, I can use it. I have already said that I will be using 16 as my balancing point. Therefore, this number must be about right. A little further than I thought. Well, about there. That is the only place on this number line where this value can go so that this sample will balance at 16. If I have another sample, there's 1, there's 2, there's 3, put those on, then this number is going to have to go maybe here, back here, slide it this way. Notice I'm not changing the mean of the sample, that's already locked in. I am defining this last value as having to be right here. Let's review what we're doing. I used that original sample statistic to estimate a population parameter. I've locked in that value. Anytime I do the math, the sample mean, the original sample mean, is going to be the point estimate for the population. Therefore, any other samples that I draw must balance at that same point. That means that I have lost 1 degree of freedom. Any 3 of these could take on independent values, but the 4th one is always going to be locked in. It is not free to vary. Here's the takeaway. Anytime you use a sample statistic to estimate a population parameter, you lose 1 degree of freedom. I'm going to explain this as we look at things like the sampling distribution and the standard error of the mean. And you'll see me use n-1 in the denominator. And that's the reason why. Because I'm estimating from a sample to a population, I'm locking in that population value, I lose 1 degree of freedom. Let me explain this in a little more cogent and mathematical way in that next video. So we're going to move on to that one. Hopefully this stats blocks idea is going to help solidify in your mind why we have to lose 1 degree of freedom anytime we're estimating from a sample to a population. Let's check that out in the next video.